Hello and welcome to Oracle Database World. Today we're going to be talking about how to simplify application development with Oracle Real Application Clusters. I'm Anil Nair. I'm the product manager for Oracle Real Application Clusters, also popularly known as Oracle RAC, and Oracle Automatic Storage Management, also popularly known as Oracle ASM. So how do you simplify your application development? Well, it all starts by making sure that you choose the right database for your application. You want the database that you choose to provide some features like seamless scalability, high availability, and disaster recovery capabilities. You also want to make sure that the database provides support for a wide variety of programming languages and APIs. The third thing is you want to make sure that your database can adapt to changing workloads. It's not just about having support for OLTP or analytical or hybrid workloads. It's also about the changing workloads and adapting to them. Finally, you want to make sure that the database that you choose is available on a wide variety of platforms, both on-premises and in the Oracle Cloud. Oracle Real Application Clusters fulfills all these requirements because of its innovative and very unique way that is architected. For example, as you can see, you see a 2-node cluster. You could have 2 or more than 2, 4-node, 6-node, or whatever. But this gives the ability that you have 2 nodes, at least in this image here, accessing the same database. This by default means you have high availability, because if one of the instances crashes for any reason, a hardware failure, whatever, you still have the other instance, which is active. So it's an active configuration. You also benefit from scalability, because if you want to have more computing power, you just add another instance or add another node. So we provide you what we call as both vertical scalability, in the sense that as you add more CPU to the instance, we make sure that we benefit from it, and also horizontal scalability, because now as you add more instances, you can scale well. So Oracle RAC is built on top of the Oracle single instance database. So that means all the programming languages that are supported by the single instance automatically get support in Oracle RAC. We also provide you with the capability that we can adapt to changing workloads. So think of it this way: you can have your OLTP application or OLTP workload of your application on instance 1, and you can have your analytical workload on instance 2. Okay, and you can make them like on weekends. You could say, hey, you know what? I actually need a lot more processing power. So maybe I'll have my analytical workload use both the instances. So you can configure it and set it up, and that's it. You just configure once and use it. Finally, as you know, Oracle RAC is available on many platforms, and it's also available in the Oracle Cloud. So you have a support for a variety of deployment choices. Now, remember, the most important thing is we can get you all these benefits without you having to change your application. This is the very important part. So how do we do all this? Well, it all starts with making sure that you connect using what we call as a service name. So let's get into understanding what is a service name. So if you remember that most applications connect to the database using some variation of, as I show there, a host name and a port name. With RAC, all we request is that you make sure you connect using a port name, host name, port name, and a service name. So a service name is an entity that is, you create once, and then your applications can use it how many over times it wants. You could have a simple URL like this, or you could have a very comprehensive URL which has all the timeouts and everything. Now, I will highlight some of the aspects of this, which is basically, if you can see, I have highlighted 2 important things. One is the host equal to something we call as a primary scan. A primary scan or a scan is actually a single client access network. Now, remember, when I introduced you to Oracle RAC architecture diagram, you have actually 2 nodes. So the application developer does not need to remember the host name of those individual nodes of the cluster. You actually can use what we call as scan, which is, in other words, you can think of it as a cluster IP. And we will make sure that regardless of where your database instance is running, on which instance of the cluster, we will redirect your connections to that instance. Okay. In this case, I've actually chosen to define in my comprehensive URL not only primary site but also disaster recovery site, because this application has everything set up for making sure that you do not lose access to the database regardless of what happens. As long as you use a service name as I've indicated there, you are good to go. Okay. Now, you would say, Anil, I like the simpler one. I would actually like to use the simpler the URL. Well, you could actually add all these attributes to the simpler URL. It just makes it a little bit hard to follow. It's much easier to use the comprehensive one with the formatting so that it's easier to debug the code, but it's your choice. So once you define the service automatically can benefit from load balancing and provides what we call as protection against failures. So how does this work? So obviously, when you have an application and you connect to the database, you can directly connect to the database, as I've shown here. Or you could say, I'm going to connect using what we call as an application server. Now, why is it application server? Well, an application server has some kind of connection pool typically, or you could just have a connection pool or directly use it. Regardless of how you do it, you definitely want to use a connection pool. Why is connection pools very important? The reason connection pools are important is because if you have, say, 100 connections from the users to the database, and they all do insert, update, delete, and then they exit out, which means the session is closed. There is a lot of overhead on the operating system to create connections and destroy them. So we can use something called as a connection pool, and that makes sure that even though you have 100 connections from the users to the connection pool itself may have, say, about like 10 connections. And they are persistent connections, which means they are not created and destroyed. Okay. Now, the connection pool has its connections as shown there to the database. On the database, even though the connection pool is not on the same host as the database, the connection pool is kept up to date on the load information and failure information of the RAC database. This is automatically done. So when you connect to the database, as I said, please use SCAN, the single client access network, which is running on the database side, and the services which are running on the database, you can configure them. And so using, as I said, host:/port/services, you can be redirected to your service that you want to use. Now, in this case, I have provided two services. One is what we call the yellow service and the white service. The white service is running on both the instances, and the yellow service is running on the instance number 1. Regardless of how you have it, as long as the user uses host:/port/ the yellow service, the connection will end up on instance 1, and that is automatically taken care of by us, as in between the connection pool and the scan listeners and everything. All of that automatically make sure that this connection request goes to the right service. Okay. Finally, as you're connecting, we'll have load information that is continuously updated. There's a process called LREG, which makes sure that the load on the system is communicated up the stack so that your connection pool is aware of all these changes. So if you have, say, a lot of work going on in instance 1, it's getting busier, and you want to tell the connection pool that, hey, if you want a connection, you should really go to instance 2. Well, that notification is sent. Now, how does Oracle RAC simplify failure detection for application? This is very important because we do what we call as a comprehensive failure detection. We also resolve it and we notify. Now, this is important because remember, if you are a user who's trying to use or reach a host:/port/ service, if you don't get a response, you don't know what is broken. So you do not know whether it's the application server is down or whether it's a network down or the entire site is down. So this is important that we do not always resort to failing over to the disaster recovery side if it's a minor error. Now, we'll get into what I mean by minor error. One of the things that we do really good is we try to reduce what we call as the blast radius. So if you have a failure, we want to make sure that the failure is correctly identified and taken action upon. So if you pay attention to, let's say, the primary site here. And suppose there is some kind of private network, the public network issue on the instance one. What would happen is the services move on to the other site automatically. We'll take care of it. The clusterware, the GI, we'll make sure the services are moved. We also make sure that we notify the connection pool that, hey, there is some problem with instance one. So you want to make sure that your sessions that you're connected to, that you disconnect, and then you connect if needed to the instance two. So a user actually is not even aware that, hey, I was connecting to instance one, now I moved to instance two. They don't even know. The second part is if it gets fixed, if it's a temporary error, if it's a temporary interruption, we know that once it's fixed, we can even move the services back. Now, you could say, you could define these things at the service level to change any of the behavior, or we will just simply take care of it. Once the things move back and the services are moved back, we also, another notification alert is sent to the connection pool saying, hey, guys, just to update you that our server number one is up. So if you want to connect, please go ahead. And that is automatically taken care of. This is very important that we do not actually, cause any failure to be always, causing this to fail over to the disaster recovery side. We want to make sure that failures that we identify, and if we can mitigate, we do it at that level. Okay. The second part is about site failure. So suppose we found out that there is a disaster and that resulted in the entire primary site being down. Now remember, if you had used the comprehensive connection URL, you would get, you had a primary scan, and if primary scan is not responding, go to the standby scan. Well, it works exactly as it is. So your disaster recovery site is an exact copy of your primary site with all the similar things that I talked about. It has also the load notification mechanism and everything as we had on primary site. Another aspect of Oracle RAC that I really, really like to talk about is the fact that Oracle RAC keeps application available during maintenance operations. So today's world, there's so many security fixes coming up. There is some patches that we need to apply at the operating system level. Sometimes there have to be, firmware patches have to be updated. So there is something that, most customers plan, which is called as a planned maintenance activity. Now, what Oracle RAC helps is all planned maintenance activity can be done in such a fashion that the user is sometimes not even aware that there's a planned maintenance going on. So that because we have multiple instances, you can actually apply the grid infrastructure patches, the database patches, and operating system patches in a rolling fashion. What does rolling fashion mean? Well, you could take one instance down, make sure that the services are moved, and then you take that instance and apply the patch, and then once it's done, you can move it back. And you can do it in a rolling fashion. This is great. However, we go a couple of steps further. We have this feature called zero downtime grid infrastructure patching. This feature allows us to apply a patch to the grid infrastructure without even taking the RDBMS or the database instances down on that node where we are applying the patch. So this is really something that we take a step further to even reduce the impact to the end user. And obviously, if you are on engineered systems like Exadata, we even allow you to apply operating system patches using ksplice without even taking down the system. Now, yes, it is specific to an engineered system because applying an operating system patch using ksplice requires us to know about the environment enough, and only on engineered system we actually have a very good understanding of what the systems and what are the operating system patches applied. So we kind of are able to do it only on, or offer this only on engineered system. Now, let's say there is, for some reason, you say, no, I still want to use rolling patching. This is something we recommend that you do. That is to make sure that you use the drain timeout in your servctl command. So even if you're stopping the instance or you're relocating the service, you want to make sure that you use this drain timeout. Now, what is this drain timeout? Now, remember in the start, I said that if you have 100 connections or 200 connections on instance one, and you do this operation where you're saying, hey, I want to apply the patch, I want to do it in a rolling fashion, what would happen is during that time, those 100 or 500 connection needs to be reconnected to the instance two. And as I earlier mentioned, that connection creation is an expensive operation on the operating system side. So connecting or creating those connections for 100 or 500 is going to have some performance impact. So having a drain timeout is like saying, hey, you have 500 connections. The drain timeout is say 5 seconds or 10 seconds. So in that period, we try to move things gracefully onto the other side. So instead of creating 500 connections immediately, you could spread those 500 connection creation over, say, 10 seconds or 50 seconds. Now, let's say it finishes even before that. Well, then the command comes back and you can move on to the next step. So this is really an important piece of advice that I can give to customers. Now, remember, the application developer does not even need to care about this. For them, they are able to get almost uninterrupted service from the database, even though there's a planned maintenance going on. Now, unplanned maintenance are a little bit more trickier because unplanned outage is a bit trickier because unplanned outages happen all of a sudden. And in this case, let's say, for example, here in this case, node 1 gets evicted for whatever reason. So the whole node is gone. Boom. Automatically, what we do is we will make sure that the services are restarted on the other instance. Now, this is great. We also move the applications, the connection to the other server. Great, this is good. Moving or creating this or relocating those connections to the other server is a very good thing, but we also make sure that the connection pool is notified. So sessions have failed over. We have done this notification. But think of all those sessions who are working. You're doing insert, update, delete, insert, update, delete. So let's say you have a banking transaction. You're doing 2 inserts and 1 update. Now, there is 100 connections, and suddenly there is an unplanned outage. Now, we don't know. We have failed over the sessions, but we don't know what state it was. How many of those were actually committed, and before the commit could be transferred back to them, whether they, got it done or not. We don't know. It just the instance just went away. Well, the good news is you can benefit from Oracle RAC's feature called Oracle Application Continuity by just doing this. You say servctl, modify the service, and make sure you enable this failover restore auto. What this does is it actually makes sure that it tracks what we call as the state information and safely replace those transactions once it fails over. So as an application developer, if you're doing 2 inserts and 1 update, you don't need to keep track of it. Once it fails over, if your service is set up with failover restore auto, we will make sure that not only we fail over the sessions, we continue from where we left off. So instead of getting an error to the user saying, hey, I got an error while trying to write to the database, you would say, no, we actually continued, and we get a notification to the end user saying, good, we have finished your work. Now, this is really, really exciting because no changes are required at the user side. All that we request or recommend is that you make sure that you use services and you enable certain features like this application continuity, and it works great. So you can see that we are doing a lot of things. Now, let me give you a contrast. So Oracle RAC improves developer productivity because there is no need to add complex logic. So think of a world where you're not using Oracle RAC. So you have this same scenario. You have users who connect to the connection pool, and you talk to the database. Now, if there is an error, let's say the user has done insert, update, transaction, and there is an error. Now, typically they can wait until TCP timeout, which is sometimes large, and get an error. So that is like forever in today's world, by the way. Or they can say, no, let me write some code that says, okay, if I don't get a response in some time, let me sleep for some time and I'll retry for some time. Now, remember, application developers are not experts on the failure timeouts of some of this infrastructure component. They don't know how long to wait for network failures. They don't know how long to wait for other components. What happens if the server is busy? They don't have a way to know this. Not all application developers know this. So they come up with values intermittently. And remember that as they change their deployment, say from on-premises to some other environment, they would find that the values that they used and tested may change over time. So if you don't use RAC, you have to add this. So this is why we say that delegate the failure handling to RAC. Once you delegate it, we'll take care of it. So it absolves a developer from adding complicated failure handling and retry logic. He doesn't have to do that. He or she doesn't have to do that. Okay. Not only that, with Oracle RAC, you get the benefit of a variety of application development paradigms. So today, if you ask any developer, they always talk about JSON or key value pair or blockchain or whatever the newer things they are so excited about. Well, guess what? You could do all of these things on Oracle. You could do all of these things on Oracle RAC. You can scale each of these things on Oracle RAC by adding more instances and all of it without making any changes to your application. Applications will automatically benefit from the scalability and high availability features provided by RAC. You don't need to do anything. So now we get into how do you get this seamless high availability and scalability regardless of your deployment choice. So let's say you are having a generic system, which I call as generic system on premises, and you have using RAC for your application, and you have used the comprehensive connect string. Now you're connecting using the host equal to generic system scan. Great. Now, how about if you want to move to, say, Exadata? If you move to Exadata, the only change you have to make is you have to update your connect string to say, hey, you remember the host colon port? Well, that's the only thing you change, host colon. And if the port number is same, no need to change that. And you are able to run your application on Oracle on Exadata. Now, think about it. We will automatically be able to benefit from running Oracle RAC on Exadata, and there is a lot of optimizations and performance benefits that you can avail of. Now you don't have to make any changes. Automatically you get benefit of it. In fact, when you move from a generic system to Exadata, typically customers see that they get awesome performance improvement. Let's say you say, no, I want to actually move to the Exadata Cloud Service or the Exadata Cloud at Customer. Well, same thing. You just change the host colon and you're all set. And finally, you'd say, no, I would like to try this autonomous database, which seems to be very popular nowadays. And guess what? Just one change. Because Oracle RAC runs on generic systems, on Exadata Cloud Services, Exadata Cloud at Customer, and is also one of the major pieces of technology that power the Oracle Autonomous Database. So just by adjusting the connect string, you can port your application between deployments. So in summary, I'd say Oracle RAC improves developer productivity because now application developer does not need to worry about anything, but they can focus on writing their business logic. So Oracle RAC provides all the scalability and high availability benefits. We provide you broad application support for various programming languages and the new application development paradigms. We provide you seamless workload management. This is important. And finally, we provide you a lot of choices of deployment. If you don't take my word, you can actually benefit and test yourself. You can leverage what we have, Oracle RAC workshops. Once again, thank you so much.